Most people walk past gold every day, not because it's rare, but because it hides in plain sight. Deep inside ordinary rocks, inside strange patterns most eyes ignore, inside simple processes nature has used for millions of years. In this full documentary, you'll see 3 real proven ways gold reveals itself without chemicals, without expensive machines, and without guesswork. These are not theories. These are geological clues, field-tested methods, and natural signs that have led to real gold discoveries. Watch closely because once you understand how gold hides, you'll never look at rocks the same way again. Gold has never been obvious. It rewards patience, observation, and understanding nature signals. If this documentary changed how you see rocks, patterns, or the ground beneath your feet, then you're already seeing the world like a prospector. Subscribe for deeper geological breakdowns, real field evidence, and investment-grade gold knowledge because the next discovery might be closer than you think. Imagine holding a rough, unpolished rock in your hand. It looks ordinary, almost worthless. Yet hidden within its veins could be a metal so rare, so desired that entire empires have risen and fallen because of it. This rock may be carrying gold, the eternal symbol of wealth and power. But here's the twist. Today, we are not talking about dangerous acids, toxic mercury, or costly industrial machines. Instead, we are uncovering the natural way to extract gold from gold-bearing rocks without chemicals, without poisons, and without shortcuts. Just pure earth science, age-old techniques, and human ingenuity. The question is, how do you separate the most precious metal on Earth from the stone that cages it without harming yourself or the environment? Stay with me, because what you're about to discover will completely change how you look at ordinary rocks. Every rock tells a story. Gold-bearing rocks in particular are nature's hidden vaults. They do not shout their presence with glittering sparkle. Instead, they conceal microscopic veins, specks, and flecks of gold locked inside quartz, iron oxides, or sulfides. In history, miners relied on fire, mercury, and cyanide to break gold free. Methods that poisoned rivers, sickened workers, and destroyed landscapes. Today though, there's a growing fascination with natural extraction. Not just because it's safer, but because it connects us with how early civilizations discovered gold without technology. So, let's begin our journey where it all starts, the rock itself. Gold rarely appears in its pure form lying on the ground. Instead, it hides inside host rocks. The most common host is quartz, a hard natural gold without chemicals crystalline mineral that forms veins through mountains and riverbeds. But quartz alone doesn't guarantee gold. To know if your rock is promising, you need to study clues. Does the quartz contain iron staining, rust-colored streaks from oxidized iron? Does it lie in areas with historical gold activity like old mine sites or river valleys? Does it appear heavy for its size, suggesting hidden minerals inside? The suspense builds here because most quartz rocks are barren. But when you find the right one, it's like holding a treasure chest sealed for millions of years. Once identified, the rock must be broken down. But without acids or chemicals, the process relies on physics, not chemistry. Ancient miners understood this. They used tools like hammers, mortars, and grinding stones. Today, you can replicate that with a geology hammer or mallet to break the rock into smaller pieces. A mortar and pestle or hand crusher to reduce fragments to gravel. Then eventually a grinding method, even something as simple as a heavy flat stone to turn the gravel into fine powder. The finer the powder, the more gold you expose. Remember, gold is malleable. It bends and flattens when struck, while ordinary rock fractures and turns to dust. This difference becomes your first advantage. Gold has one property that makes it unique. Its incredible density. It is nearly 20 times heavier than water and far denser than the quartz or host rock surrounding it. This means if you mix crushed rock with water and shake it, the lighter material will wash away, leaving the heavier gold particles behind. This principle is called gravity separation, and it's been used for thousands of years. Think of the classic gold pan. Swirling, washing, and letting water carry away lighter sand while the heavy gold settles at the bottom. But here's where it gets interesting. Without chemicals, this method alone can isolate visible gold. If the host rock contained enough free-milling gold, you'll begin to see tiny flashes of yellow at the bottom of your pan. At this stage, excitement builds. You've crushed, you've panned, and now you hold a concentrate. But the story doesn't end here because not all gold is visible. Some is hidden as microscopic particles. To the naked eye, it's still trapped in black sands, iron oxides, and heavy minerals. So, how do you coax it out? The next steps combine ancient wisdom with natural science. Heat, fire, and persistence. And the best part, still no toxic chemicals. For centuries, fire has been humanity's greatest tool for separating metals. The process is simple in concept, but requires patience. 1. Heat the gold-bearing concentrate in a natural furnace or crucible. 2. The heat drives away impurities, breaking down sulfides and oxides. 3. Gold with its high melting point remains behind as a glowing bead. This is called smelting, but traditionally it was done with toxic fluxes. However, there are natural safe fluxes you can use instead. Crushed glass, borax, or even sand, which lower the melting point of impurities and allow gold to separate more cleanly. The suspense here is electrifying because as the fire rages, you're not just heating rock. You're recreating an ancient transformation that turns stone into treasure. Imagine pulling a crucible from the fire, letting it cool, and then breaking away the slaggy crust. Inside lies a tiny bead, heavy beyond its size, glowing faintly even after the flame dies. This is gold freed from rock, without cyanide, without mercury, without harm. The moment is dramatic. This bead may be small, but it represents the Earth's story condensed over eons. It also proves something remarkable. You don't need chemicals to win gold from stone. Only knowledge, persistence, and patience. But we are not done yet. Even naturally smelted gold contains impurities, traces of silver, copper, or iron. Refining without chemicals becomes an art form where traditional methods come alive. Ancient smiths hammered, reheated, and hammered again, driving out non-gold metals. Over time, the bead grew purer, its yellow hue deepening. Today, modern hobbyists replicate this with small forges and repeated melting, still relying on physics, not poison. The result, clean natural gold, safe to handle, and safe for the earth. Why this matters today? You might wonder, if chemical methods are faster, why return to natural techniques? The answer lies in 3 powerful truths. 1. Safety. No exposure to toxic mercury or cyanide. 2. Sustainability. No rivers poisoned, no soil destroyed. 3. Connection. A deeper bond with the earth and the heritage of gold seekers before us. And here's the most surprising fact. Some of the world's richest discoveries were made this way. Simply crushing, washing, heating, and repeating until nature revealed her treasure. The suspense continues. We've explored identifying rocks, crushing them, washing for gravity separation, and even smelting with natural methods. But the story of natural gold extraction is far from over. Because the real challenge isn't just freeing the gold. It's maximizing recovery without losing even the tiniest flake. To collect pure gold, this washing must be done again and again. Each cycle concentrating the material. Larger fragments shine early, but the real wealth is in the dust. The specks so small they could slip through careless fingers. And here is where skill becomes art. Maintaining patience as each swirl uncovers another gleam. For some, the process ends here with a pouch of fine grains. But the forgotten method goes deeper. Because raw concentrates still contain impurities, bits of black sand, magnetite, or other heavy minerals clinging alongside the gold. And to isolate the king of metals from its companions, one must learn the final steps. Nature provides yet another ally, magnetism. Many impurities like magnetite respond to a magnet's call, while gold remains untouched, indifferent. By carefully drawing a magnet across the concentrates, sometimes wrapped in cloth to prevent contact, the prospector watches the black sands leap away, leaving behind a purer, brighter residue. This is the moment suspense builds. What remains is smaller in volume, but greater in worth. Every grain here is closer to being pure. At last, imagine holding in your hand a small glowing bead formed from fragments once hidden deep inside stone. This bead is not just gold. It is history, science, and mystery, fused into a single shining object. Each particle of it was once locked away for millions of years, waiting for human hands to find, free, and cherish. And here lies the suspenseful truth. This method, though forgotten by many, was the very foundation of the great gold rushes of history. It built empires, toppled kingdoms, and set thousands of seekers wandering across wild frontiers, all with nothing more than rock, water, gravity, patience, and fire. What is gold if not a reflection of human spirit? It resists corrosion. It resists destruction. And yet, when treated with care, it bends, melts, and takes new form. The prospector who extracts gold without chemicals does more than claim wealth. They honor nature's process unchanged for millennia. And perhaps the greatest treasure of all is not the beat in the hand, but the knowledge in the mind that in a world of shortcuts and chemicals, there remains a path carved by patience, endurance, and respect for nature. So now when you see a rock glittering with possibility, remember this. The earth still hides treasures in plain sight, waiting for those who know the old ways. No acids, no chemicals, no shortcuts, only the raw forces of nature. Now that you've seen how gold can be revealed without chemicals, the next question becomes even more important. How do you know where to look in the first place? Nature leaves patterns behind. And those patterns are rarely random. Let's move to the next sign that has guided prospectors for centuries. The earth never shouts its secrets. It whispers them layer by layer through textures, colors, and patterns that most people step over without a glance. But to those who know what to look for, these patterns are more than random streaks or veins. They are nature's rock patterns that lead to gold-coded map leading to hidden gold. Every mountain, every slope, and every cracked boulder could be silently holding traces of the precious metal that built empires and broke nations. Today, we'll explore what these rock patterns mean, why they form, and how you can learn to read them like a prospector's diary, without chemicals, without expensive tools, and without risking your safety. Imagine you're hiking across a rugged hillside. The rocks look ordinary, gray, dull, lifeless. But then you notice something different. A strange crisscross of veins, an unusual color pattern, or a texture that seems out of place. Most people would ignore it, but a trained prospector stops because that subtle difference might mean you're standing right above a natural gold-bearing system. You see, gold doesn't appear randomly. It travels through geological highways. Fractures, cracks, and mineral veins created by heat and pressure deep within the earth. Over millions of years, molten fluids carrying gold move upward, cooling and depositing traces of it inside certain host rocks. And these rocks, dear listener, tell the story through their patterns. The first sign that often goes unnoticed is vein formation. When you see thin thread-like lines running through solid rock, especially white or milky ones, you might be looking at quartz veins. Quartz is nature's favorite carrier for gold. But not every quartz vein is worth your excitement. The secret is in the pattern. If the vein cuts across multiple rock layers, bends or widens irregularly, it might have been part of an active hydrothermal system, one capable of carrying precious metals. Sometimes these veins appear as ladder-like structures or networks known as stockworks. In old mining regions, such patterns were the first indicators that gold was nearby, often right where those crisscrossing lines intersected. Now, let's move deeper. The second kind of pattern isn't about veins at all. It's about iron staining. When iron-rich minerals oxidize, they leave rusty or reddish-brown streaks on the surface of rocks. To most people, this is just discoloration. But for gold hunters, iron staining is a red flag that screams something mineralized passed through here. Gold is usually accompanied by iron, copper, and other metals. So where you find rust-colored surfaces, you're likely looking at the scar of an ancient mineral flow. And here's the key detail. If the rust patterns align with small cracks, or if they form halos around quartz veins, you might be standing on what prospectors call feeder zones. These are areas where gold-bearing fluids once pushed upward. Take a closer look, though. Don't rush. Nature signs often appear together. Quartz veins intersecting iron stains, sometimes with patches of clay alteration. If the rock around those veins looks bleached, crumbly, or strangely soft, that's another signal. Hydrothermal alteration changes the original minerals into lighter clays or saracite, bleaching the rock surface. It's like nature's fingerprint left behind after the gold-bearing fluids vanished. Now, let's move into textures. One of the most misunderstood clues. When gold-bearing fluids cool inside cracks, they sometimes cause rocks to fragment and reseal. This creates a braided texture. Imagine shattered rock pieces glued together by a new mineral. If those cementing minerals are quartz or iron oxide, it's an even stronger sign that this zone was once mineral-rich. In the field, brachiated patterns often appear near fault zones or fractures where fluid flow was intense. Stand on one of those and you're literally on the same geological plumbing that once delivered gold to the surface. But here's something even more fascinating. Banded patterns. In some quartz veins, you'll notice alternating light and dark layers almost like the stripes of an AGOT. Those bands are records of multiple pulses of mineralization. Each band might represent a separate wave of hot fluid depositing gold and other minerals. The more bands you see, the more cycles of mineral activity that area experienced. Old-timers used to say, the more layers, the richer the heart. They weren't wrong. Heavily banded quartz often came from systems that recharged and redeposited gold over and over again. Now, let's turn our eyes to the surrounding rocks, the host rocks themselves. Certain patterns in host rocks can dramatically increase your odds of finding gold nearby. One example is folding and shearing. When you see rocks bent or twisted, sometimes forming zigzag layers or wavy bands, that means the area experienced immense pressure. These zones are crucial because fractures created by folding often became pathways for gold-bearing fluids. Old geological maps mark these as shear zones or contact zones. And even today, professional exploration teams start their drilling programs near these structural patterns. But even without maps or fancy tools, you can spot these signs yourself. Stand on a slope and look for where rock layers seem disturbed, where lines of strata suddenly bend or break. If you also notice quartz running along those breaks, stop and take a sample. You might be standing at the very contact where heat, pressure, and fluid met. The perfect recipe for gold deposition. Let's not forget color zoning. Another overlooked pattern: when different minerals interact, they paint the rocks in shades of white, yellow, red, or even purple in gold-bearing areas. This color zoning often appears in halos, red to brown from iron oxides, fading into white from quartz and clay alteration. Now, let's combine everything we've seen. You're standing in a dry hillside, the air heavy with dust. Around you, the rocks show streaks of rusty red, small veins of quartz, and faint bleaching where the stone looks almost ghostly. To an untrained eye, it's nothing. But to you, it's a pattern, a code. Quartz veins tell you the gold had a path. Iron staining tells you mineral fluids once moved through. Alteration tells you the chemistry change. And the striation shows the earth fractured, healed, and fractured again. All of these together form what geologists call a mineralized zone. And that's where the gold hides. You see, finding gold isn't about luck. It's about learning to listen to the ground. Every pattern, every crack, every discoloration is a word in nature's hidden language. Those who learn to read it don't need luck. They just need patience and awareness. Now, before you rush to the field, here's a critical reminder. Gold can travel far from its original source. Erosion breaks down those mineralized rocks, washing gold particles downhill and into sediments. So, if you find these patterns higher up a slope, follow the terrain downward. The heaviest particles, including gold, settle in natural traps like bends and gullies or behind boulders. By reading the rock patterns, you're not only identifying where gold once formed, but also predicting where it might have migrated. Sometimes, even when gold veins have long eroded away, their presence is still written in the rocks through rusty scars, bleached zones, and crumbled quartz debris. That's why old mining regions often appear lifeless and stained. The very colors of the earth tell the story of what was taken from it. But here's where modern prospectors have an advantage. You can combine visual observation with simple non-chemical methods. Start with identifying mineralized zones based on these patterns. Then use gentle panning from weathered debris around those zones to confirm whether gold particles are still present. No acids, no mercury, just eyes, knowledge, and patience. And when you find a small flake or two, trace them back uphill until you locate the source pattern that first caught your attention. That's the real trick. Following the clues backward from sediment to bedrock. Every piece of gold you find in a pan had to come from somewhere. And the rocks will tell you where if you learn their language. The deeper secret behind these patterns lies in time. It took millions of years for heat, pressure, and chemical reactions to write these stories in stone. You're not just looking for gold. You're reading Earth's autobiography. Each vein and fracture is a sentence. Each iron stain is a comma. And each glimmer of gold is the period that ends a long geological paragraph. When you begin to see rocks this way, you'll realize that gold isn't hidden. It's revealed in plain sight, just disguised behind patterns that only the observant can decode. So, next time you walk through the hills and notice a strange pattern in the rocks, a rusty vein, a shattered formation glued by quartz or bleached surfaces in an otherwise gray hillside, stop. You might just be standing above a deposit that took the earth eons to create. Gold doesn't hide from everyone. How hidden gold is revealed from rock, it only hides from those who aren't paying attention. If you've learned to recognize these signs, then congratulations. You're already one step closer to finding real gold. Recognizing gold-bearing patterns is only part of the story. Sometimes gold stays locked inside rock, hidden by time and pressure. But when heat, force, and natural fractures come together, gold finally reveals what was concealed. This final method shows how hidden gold is physically released from its host rock. They look ordinary, rough, ugly. The kind of rocks most people would kick aside without a second glance. But what if I told you that inside these dull and lifeless stones could be one of the Earth's purest treasures? Gold. It sounds unbelievable, doesn't it? Yet for centuries, nature has hidden gold in the most unexpected forms. Not in glittering nuggets lying openly in streams, but deep inside rocks that seem completely worthless. Today, we're not just talking theory. We're going to uncover a natural process. One that doesn't require chemicals, mercury, or fancy machines, but instead uses what nature itself provides: fire, water, and patience. This is how you find gold in rocks that everyone else ignores. This is where it begins, with the search. When you start looking for gold in nature, you must unlearn everything you think you know about beauty. Gold doesn't always hide inside beautiful, shining quartz crystals. In fact, many of the richest deposits are concealed within rocks that appear dull, rust-cold, even broken. You see, the Earth's crust tells stories, and those stories are written in color, texture, and formation. Look for rocks with iron staining, those deep red and brown patches caused by oxidized minerals. They might look like rusted scrap metal, but that's exactly what you want. Iron oxides and sulfides often indicate hydrothermal activity. The same process that once brought molten gold up from deep underground veins. If you see tiny metallic sparkles, but they don't look like glittering gold, don't walk away yet. Many of these flecks are pyrite or arenape, minerals that form alongside gold. These are the clues, the whispers from the earth that tell you gold might be near. Once you collect a few candidate rocks, iron stones, quartz with rusty veins, or dense black and brown stones with weight, the next step begins. It's time to reveal what's hidden inside. For thousands of years, before modern refineries and chemicals, prospectors used fire to separate the worthless from the valuable. Fire in its purest form doesn't destroy gold. It reveals it. When you heat a rock, something remarkable happens. Thermal expansion. Each mineral inside that rock expands at a slightly different rate when exposed to high temperatures. That means under the heat, the internal bonds start to weaken. Tiny fractures form. The rock begins to loosen its grip on whatever is trapped within, including gold. Now, this process isn't about melting gold. It's about breaking the prison that holds it. You don't need industrial furnaces. Even a simple controlled fire fueled by charcoal or dry wood can create enough heat to fracture softer mineral bonds. The key is patience. Let the fire do its work slowly. Rushing it might cause the rock to burst unevenly, wasting both material and effort. But when the heat has done its job, you'll notice a subtle change. The surface dulls. The rock looks tired, as if it's about to tell its secret. And that's when you introduce nature's second element. When the red-hot rock meets cold water, nature performs one of its most powerful transformations. The sudden temperature change causes thermal shock. The rock cracks open from within. You'll hear it. Small pops and cracks as the water penetrates the fractures, widening them. This isn't just a satisfying sound. It's the sound of progress. The rock is breaking apart layer by layer, exposing its inner matrix where gold might be trapped. Now, as you lift those cooled rocks, you'll notice they feel lighter. Some have split cleanly. Others crumble between your fingers. That's when the real revealing begins. What was once solid stone now breaks easily. Inside, you'll notice veins, metallic threads, or dull patches, all of which could indicate gold. Crushing doesn't mean pulverizing everything into dust. It's a methodical process. The goal is to reduce the rock into smaller pieces until you can examine what lies within. And sometimes you'll see it. That faint buttery glimmer that refuses to tarnish no matter how much you rub it. That's not pyrite. That's gold. When gold forms in nature, it bonds with quartz, sulfides, or iron-rich minerals. The heat and cooling process frees it from its original bonds. What you're doing now, crushing, is simply helping the earth finish what it started millions of years ago. Each tap, each crack brings you closer to what prospectors once called the mother's gift. But there's one more step. The separation. And it doesn't need any chemicals. Just clever observation and patience. Gold is one of the heaviest elements found in nature. That simple truth can be your biggest advantage. Take your crushed material and place it in a shallow pan or wide container filled with clean water. Gently swirl it. Don't rush. The lighter materials, sand, dust, and rock, will float or move to the top. But the heavier particles, including any gold, will stay stubbornly at the bottom. This natural principle of gravity separation is the foundation of panning. It's how ancient civilizations discovered gold long before chemistry existed. As you tilt the container slightly and let water wash away the light debris, what remains might surprise you. Tiny golden fragments, specks, or even flakes glinting in the sunlight. Each one tells a story older than humanity itself. For most people, rocks are lifeless. But for those who understand the Earth's language, every fracture, color, and shimmer is a clue. You've just transformed what appeared to be worthless stone into something extraordinary using nothing but natural forces, fire, water, and gravity. The process might seem simple, but it's one of the oldest forms of natural gold liberation on record. It's proof that you don't always need chemicals or machines to work with nature. Sometimes all you need is understanding. And here's the secret most overlook. The real value isn't just in the gold you find, but in learning how nature conceals and reveals its riches. That knowledge is what separates a casual explorer from a true prospector. You didn't just extract gold today. You uncovered a truth that's been buried for centuries. Gold has never been obvious. It rewards patience, observation, and understanding nature signals. If this documentary changed how you see rocks, patterns, or the ground beneath your feet, then you're already seeing the world like a prospector. Subscribe for deeper geological breakdowns, real field evidence, and investment-grade gold knowledge, because the next discovery might be closer than you think.